Hi guys, and welcome to another video. This week we're going to be talking about functions and loops. So the first thing you're going to need to do is open up a Jupyter notebook. Now if you can't remember how to do that, if you're using Windows, you're going to need to hit the Windows key and type CMD to find the command prompt, and then once you've got that open it'll look something like this. I'm not using Windows so it looks slightly different, but it'll be something similar. And then what you're going to need to do is type Jupyter notebook and then hit enter and navigate on over to where you've saved your files. In my case, I've already got one running, so I can just get rid of that. And we're going to open up the notebook called Functions and Loops. So just a recap from last week, some of the things we looked at were variables. Now, a variable is a kind of place where you can store some small piece of data. Well, actually, it doesn't have to be small, it could be any size, but the basic variable types are typically small things. So we've got some examples here. We've got, we're assigning a variable here called A, which is going to be equal to 5, and B, which is equal to a string, enclosed in quotes, hello, and C, which is a list containing the numbers 1, 2, 3. So these are just some examples of some really basic data types, and the way that we assign variables is with the equal sign. Now we can always check what's inside a variable by printing it. So we can go print A, print B, print C, for example. Just to let you know, guys, by the way, these bits of code here, these aren't actually inside Python cells, so they're not going to get run. These are just kind of, you can think of them as just images, pictures of code. Another thing we looked at was comments. So anything that follows a hashtag isn't going to actually be run when we look at when we come to run the code. It's just kind of a way that you can add little labels to your code and make things easier to read, both for other people and for you in the future. Because believe it or not, one thing that often happens in your coding is you write some code, you forget to comment it, you go away, you come back, a couple months later, you look at it and you think, oh my god, what is going on here? I don't understand any of it. So actually, comments are useful for yourself as well. Types. So each kind of piece of data will have a type associated with it. So we can see here we've got A is a number, B is a string, C is a list. We looked at maths. So when we're dealing with numbers, we can do the usual maths operations. So addition, multiplication, subtraction, division, all that type of fun stuff. And we also looked in a bit more detail at lists. So lists are basically just, they're a sequence of other things. So they could be strings, they could be numbers. You could even have a list of lists. It can get pretty meta. You can have a list of really anything. And it doesn't matter. All the things in one list don't necessarily have to be of the same type. They often are, but they don't have to be. So here we've got a list containing dog, turkey, 65, 100, and parrot. And the way that we can kind of get each individual item in the list is by, for example, saying print my list 0. So that will actually be the first element in the list, because the list always starts from 0. So print my list 0 would print dog, and print my list 3 would print 100. So we can also sort of override individual items, so we can set things. So once we've got my list, which is equal to this thing, we can set item 0 to be 100. So now the list would be 100, 6, 7, 8. And we can also add a new item onto the end of the list by using the word append. So if we've got my list 3 is 5 sheep 17, if we do my list 3 dot append, open brackets, fish as a string, then the new list is going to be 5 sheep 17 fish. There's also a few keywords that we can use to do special things with lists. So we can use the len keyword. Now that'll work on any list with containing anything in it. And that's going to tell us the length of the list. So here, 2, 4, 6, 8, 10, it's going to be 5. We can do sum. Now this is only going to work if we've just got numbers in the list, because you can't sum together words really. So this is going to add up all the numbers. Max, again, only works on numbers, will tell us the largest number in the list. Min will give us the lowest number of the list. And the final thing we looked at were conditions. So when we write code, we can do things like, we might want to do things like, if this number is bigger than that number, do something else. If these two things are exactly the same, do something. and we had a look at that, and we showed how you can do these kind of things. So if A is greater than B, and then we kind of indent out, we do a tab, and then anything that's inside that indent will only be executed if that condition is true. And then we can also have this thing else, where we do, so if something is true, run this bit of code, else, i.e. if that thing is not true, run this bit of code. Cool, so new topic for today is functions. Now functions are really, really, really important in programming. You will see them again and again and again. And you can think of a function basically as a kind of machine that takes in some input and produces some output. So this is actually quite general. So for example, it could take in a number, and then it could add 5 to that number, and that's what you get out. Or it could take in a string, say a name. So you could pass in Mike, and then the function would output another string which says hello Mike, for example. So basically a function is something that takes in any kind of input, does something to that input, and then outputs something else. It can also take in more than one thing and output more than one thing, but the most simple case is it just takes in one thing, does something, outputs another thing. And by thing, I mean some kind of variable, so some kind of data. So let's have a look at how we write a function in Python. So the very first thing that we always need to do when we write a function in Python is we need to use the keyword def, which is short for define. So you cannot write a function without using the word def in Python at all. So you definitely need that keyword def. So that's the first thing, we're going to do def. Now the next thing is we need to give our function a name. And when you come to name a function, it's basically like how you would name a variable. So you can use letters, you can use numbers. It doesn't matter too much as long as it doesn't start with a number, it has to start with a letter. So in this example, we are creating a function and we're calling it squared. So we go def squared. Now the third thing we need to do is we need to tell the function what it's going to take in as the input. And the way that we do that is we go def squared, and then we open some brackets, and then we're going to put a variable name in this bracket. So in this case, we're doing def squared of x. So which is basically saying our function is going to take in one thing, and we're calling that thing x. We haven't, so far we don't know what x is. It could be a number, it could be a string, it could be a list, it could be anything. But all we know at this point is that we're taking in something and it's called x. So the next thing that we need to do is put a colon. So that finishes off the first line. So we go def squared inputs, enclosed in brackets, colon. And then we have to use a tab. So we put a tab and 4 spaces, or 4 spaces, tab or 4 spaces. They're basically the same thing in Python. Python doesn't care. Either is fine. And then basically whatever follows after that tab or after those 4 spaces is going to be inside the body of our function. So we're going to def name inputs colon tab. And then here in this example, what we're doing is we're creating a new variable called y, and we are assigning that variable as x multiplied by x. So basically this function is implying that we're expecting a number. So x is going to be some number, and then we're going to create whatever x gets passed. So it could be 5, could be 10, could be 1,000. Whatever we pass in, we're going to create a new variable called y, which is going to be x times x. So if x was 5, then y would be 25. If x was 3, y would be 9, etc. Finally, we have to tell this function what we want to return, so or output, and for that we use the keyword return. So basically, in this case, we want to return x squared, so we're going to return y, because we just assigned y as x times by itself. So the whole function reads define def squared of x, and then we colon and we tab out, and then we're going to do something to that x. What we're going to do to that x is we're going to create a new variable called y and assign that x times x. And then still tabbed out, we're going to return y. Now the last thing is that once we've done that and we've run that code, we can basically use that function x as many times as we like on anything, any different type of input. So in this case, we've got a is squared of 5, and we're going to print a. So we're assigning a variable, and what it's going to be is whatever is returned from squared of 5, which is going to be 25. So your first exercise is to look at this code, review the steps, and write them out. So basically complete this function, squared. So write it out from scratch in this cell below, and then test it like in step 6 with some different things. So it doesn't have to just be 5. You can put anything in here. So it could be a equals squared of 1,000,000. It can be, b is squared of -10 or whatever. Cool. So that's exercise 1, and then in exercise 2 here it says look carefully at the function called squared that you've just written. Now we're going to try writing a new function called add1. This function is going to look very similar. So it's going to still, because we're writing a new function here, it's going to still have the word def. It's going to have a name, which in this case is going to be add1, and it's going to take something in. But in this case, we don't want to return that number squared. We want to return that number plus 1. So the function is going to be slightly different, and see if you can work out in what way that function is going to be different. Okay, so we might want to write a function that doesn't just take in one thing. It might want to take in more than one thing. And the example here that I've given is kind of a silly example, but it's imagine that you've got a factory that makes ice cream. You want to take milk, sugar, and chocolate, mix them up, freeze it, and then you get out ice cream. So you might want to take more than one thing and combine it in some way, perform some kind of operations on those individual things. Whatever you do with those things, you want to output something at the end. So now the actual real example that I'm looking at here is the area of a triangle, right? So you might have seen this in maths class. If you have the base and the height of a triangle, then the area is always half times base times height. So we could think of this in terms of a function, right? So we could write a function called triangle area here, which takes in a base, it takes in a height, and these two things are numbers. And then the area is going to be the base times the height divided by 2. And then we're going to return that area. So if we tried running that function on some real values, we could have triangle width is 10, triangle height is 15, and then we're saying my area is triangle area, our function that we defined, on triangle width and triangle height. And if we print my area, then that will print 75, because that's 10 times 15 divided by 2. So again, exercise 3 is just copy out this function and try running it on some numbers of your own. Now be careful when you're copying out the function that you remember to do def, you remember to give it a name, you remember to put a colon, and you remember to tab out, and you remember to use this return keyword. Okay, so exercise 4. So last week, if you remember, we looked at finding the mean and range of a list using these functions len, sum, max, and min. And now, if you manage to do that exercise right, then basically the idea was the mean of a list is going to be basically the sum of all the numbers in the list divided by the length of the list. So, for example, if I have a list which has 1, 4, and 7, say 1, 4, and 7. The mean of that list is going to be 1 plus 4 plus 7 divided by 3, because there's 3 things in that list. So it would be sum of the list divided by len of the list. And similarly for range, the range is the difference between the biggest and the smallest number. So the range of a list will be max of the list minus min of the list. So we can kind of do these things of mean and range just by using these len, sum, max and min functions. So in that case, we, when we were doing it before, if we wanted to find the mean of a list, we had to just do that for every single list. So if I gave you a new list, you'd have to write, okay, len of list divided by, sum of list divided by len of list. And if I gave you a new list, you'd have to do, okay, sum of new list divided by len of new list. But the point is here, instead of doing that, we can write a function. So we can write a function that takes in a list, and then what it does is it finds the sum of that list, it finds the length of that list, and then it returns the sum of that list divided by the length of that list. So this is now a really general piece of code, and it will work for any list that you decide to give it. And the same is true for range, except you're using max and min that time. So in exercise 4, what I want you to do is write two functions, one which finds the mean of a list, and one which finds the range of a list, and you should call these functions list mean and list range. So have a go at that, see if you can do that one. Okay, so the next topic we're going to look at is loops. So imagine that you had lots and lots and lots of triangles, right? So you had the base and the height of loads of triangles, and you've written this function which tells you how to calculate the area of given a base and given a height. But you don't really want to go through and type that out 100 times. So let's say you had 100 pairs of bases and heights. You don't want to go, okay, area 1 is triangle area of base 1, height 1, area 2 is triangle area of base 2, height 2, blah, 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 because that would take ages and it would be really pointless. So there is a much quicker way of doing that in Python, and it is called loops. But before we solve that specific problem, we're just going to look at loops a bit more generally. So what do they do? So the basic idea of a loop is that we want to go through each item in a list or sequence. So let's look at this example here. We've got dog equals Freddy, 9, true, 1.1, 2001, and frog football. And then the basic way that we go through each one of these items in this list is we do this thing here. So we say for item in dog. Now, item and dog don't have to be called that, so it could be for J in dog. I mean, in this case, dog is our list, so we do want to go through that. But item, we can call that anything. So we could say for whatever, for for thing in dog, whatever. But the key thing here is that we need to do for something in our list, and then we do a colon again, similar to a function, and then we tab out, and then we do something with that item. So what's happening here is we're going to go through this list, and it's basically going to loop through this piece of code here, and each time it's going to update what item is. So item first is going to be Freddy, then item's going to be 9, then item's going to be true, then item's going to be 1.1, blah, blah, blah. So if we do this for item in dog, colon, print item, it's going to go through each item and it's going to print each one. So you could basically just read this piece of code as for each item in the list dog, print that item. And again here, so I'm just saying again that it doesn't matter what you call item. So here for I in dog, print I, and for item in dog, print item in dog. Those going to do exactly the same things. Okay, so your exercise 5 is to copy out this code here and run it. So a really common situation in Python is when you want to go through a list of ascending numbers starting from 0. You'll see why this is a really common thing in a minute. But so what we could do is we could write a new list. We could write a list called numbers equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can go for I in numbers, print I. But because this situation is so common that Python basically gives us a special function for this called range. So instead of saying numbers equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we go numbers equals range 10. Now range 10 will basically give us a list which has length 10 but starts at 0. So what that means is that 10 isn't actually included in that list. So it's a slightly confusing, but range 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Range 5 is 0, 1, 2, 3, 4. Range 100 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 up to 99. So whatever number you put into range, it's going to always start from 0. It's never actually going to get to that number. It's just going to stop one short of it. Might seem a bit confusing, but that's actually quite useful, and we'll see why in a second. So here we go, we're just explaining, so yes, actually range, we often just pass one thing into range, but actually it can take up to 3 things. So you can see here range starts from range, we put in 3 things. If we put in 3 things, then it's going to be the first element, the last element, and the step. And we remember the last element is never actually going to be reached. It's always going to stop short of that. So range 0, 10, 2 would actually be 0, 2, 4, 6, 8. Because we start at 0, we end just before 10, and we do it in steps of 2. But actually the most common thing you'll see is you won't see it with 3 elements, with 3, with 3 arguments. You'll just see it with 1. So that's a really common situation. Okay, and we're just saying here, remember, just as with if statements, we need to put a colon when we're looping through something, and we need to tab out. Okay, so exercise 6, just have a go at doing this. So just do some different ranges and loop through them and print the numbers using this kind of syntax that we've just looked at above. Okay, so now back to triangles. So that was the initial thing we were looking at. We had a bunch of triangles, bases and heights, and we wanted to find out all of the areas. So this is what we're looking at here. So if we'd had a kind of list holding all the bases, so this is a list which has length 100, and it goes 3, 5, 4, 7, 5, blah, 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 9. Heights similarly, 5, 3, 6, 8, 7, blah, 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 3. And then we basically want to have a list of areas of the same length. So this has a length of 100, this has a length of 100. Now we want to find out all the areas made up of these pairs. So basically the first triangle has a base of 3 and a height of 5. The second triangle has a base of 5 and a height of 3. The third triangle has a base of 4 and a height of 6, etc, 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 etc. So the way that we could do that is we could say for I in range 100, we're going to create a variable called area, and we're going to find that by doing triangle area of bases I and heights I. So what's going on here? So this thing here with the square brackets, what we're doing is we're saying, give me the ith element in bases. And here we're saying, give me the ith element in heights. So bases is a list, and so is heights. And as we go through this loop, so for I in range 100, I is going to get updated. So I is going to start at 0. So when we enter this area, the first thing I is 0. So it's going to be area equals triangle area of bases 0 and heights 0. And bases 0 is 3 and height 0 is 5. So area is going to be the triangle area of 3 and 5. And then we're going to do areas dot append area. So that means add on this thing here, area, to this list, areas, which is currently empty. Then once we've done that, it's going to go back, and I is going to become 1. So then it's going to say area equals triangle area of bases 1 and heights 1. Now bases 1 is 5, heights 1 is 3. And again, areas to append this area. So now area is going to have a length 2. So it's going to be the triangle area of 3 and 5, and then it's going to be the triangle area of 5 and 3. And then we just repeat. So now I is going to be 2, area is triangle area of bases 2, which is 4, and heights 2, which is 6. And then we're going to append that area to the list areas. So areas is now length 3, and so on, and so on, and so on. So we're going to keep doing this all the way up until I is 99, which basically means it's the very last element of bases and heights. So it's going to be 9 and 3. And we're going to have a list of areas, which is the same length as bases and heights, which holds all of those areas, which is a lot faster than typing out that 100 times. Okay, so the final exercise in this notebook is to do something very similar, but this time we're going back to that idea of calculating the mean of a list. So hopefully you've already written a function called listMean, which takes in a list and then it outputs the mean of that list. So the example here is we've got a bunch of different classes and we've measured the height of all the kids in that class, and we want to find out what the mean height for each class is. So the way that we've structured this data is that we have this variable here called data, which is a list. Data itself is a list. And then each item in data is itself a list. So the first item in data is this list. Then we've got comma. The second item in data is this list. We've got comma. The third item in data is this list, and so on. So we've got a bunch of different lists which kind of have different sizes. And the idea is we want to loop through each element in data. So we're going to start with the first list, then we're going to go to the second list, then we're going to go to the third list. And then for each of those lists, we want to find out what the mean of that list is. And the way that we're going to do that is using our function listMean that we wrote earlier. So we're going to loop through each list in data, and we want to print out the mean of each list. So have a go at that if you can. And once you've finished that, you have completed the notebook for the list for the week. So well done.